Students, in this problem, they're giving us an equation, and they're giving us three masses. Two of the masses are for reactants. In my case, the red numbers are 1 gram for salicylic acid and 1.33 grams for the other reactant, acetic anhydride. They also give us some information about the number of grams of product of one of the two products that is formed. Anytime that you've got information about more than one reactant, it's going to be a limiting reagent problem. And so that means at least half of the work is to figure out which of the two reactants, the salicylic acid or the acetic anhydride, is limiting. And that's really most of the work right there. Let's first record the masses that they gave us. I already wrote down the equation and the molar masses of the relevant substances here. Salicylic acid, my red number was 1 gram. Acetic anhydride was 1.33 grams. And in my problem they said 1 gram of aspirin was produced. In order to figure out a limiting reagents problem, you really have to do the calculation twice, or at least as many times as there are reactants in the equation. So first, if all of the salicylic acid reacts, and salicylic acid is C7H6O3. If all of that reacts, then I would carry out my calculation like this. In my problem they said 1 gram of the salicylic acid, C7H6O3. The molar mass of that substance is 138 grams per mole. In the equation that they gave us for this problem, all of the coefficients were 1. So for every 1 mole of salicylic acid, we'll produce 1 mole of aspirin, which is mathematically doesn't change anything, but it's really important to know which substance you're dealing with. And then lastly, we'll use the molar mass of aspirin to figure out how many grams we would expect to get if all of the salicylic acid reacts. If you follow the units, grams of salicylic acid crosses out, moles crosses out, moles of aspirin crosses out, and you're left with grams of aspirin. And if you punch all of that on your calculator, multiply across the top, multiply across the bottom, and divide, you would get 1.30 grams of aspirin. Okay, so that's half the work. What if salicylic acid weren't the limiting reagent? What if the other thing, the acetic anhydride, were limiting and all of it reacted away? And sometimes the common names of chemicals can be confusing. So I'll list the formula right next to it. So if all of the acetic anhydride reacts away, then according to my red numbers, that would be 1.33 grams reacts away. The molar mass of acetic anhydride I had figured out up above is 102 grams per mole. And if you look at the coefficients in the equation, everything has an implied coefficient of 1. So that means that for every 1 mole of acetic anhydride that reacts, you could expect to get 1 mole of aspirin produced. So it's a 1-to-1 molar ratio. And then the last conversion factor involves aspirin's molar mass, which we had figured out was 180 grams per mole. If you crunch all of those numbers, multiply across the top and multiply across the bottom, you would get 2.35 grams of aspirin are produced. So now we compare. If all of the salicylic acid reacts, you get 1.30 grams of aspirin. If all of the other reactant, the acetic anhydride, reacts, you get 2.35 grams of aspirin. Which one is correct? Whichever one is lower, because a limiting reagent limits the amount of product that can be produced. So the 1.30 grams is the amount that you would expect to get. We call that the theoretical yield for this reaction. The 2.35 grams is not a valid answer. But we had to work it out just to figure out that it was the bigger number and therefore the wrong one. So that's really, really important. That's most of the work right there. So we had determined that salicylic acid produces a lower amount of aspirin produced and is therefore the limiting reagent in this problem. The theoretical yield is however many grams of aspirin that are produced by the limiting reagent. Now, we have another piece of information that they gave us. They tell us something about how much aspirin was actually produced. This is what the chemist actually got out of running the experiment. The actual yield is 1 gram. The theoretical yield is 1.3 grams. So we have one last piece of this problem. It's to calculate the theoretical yield. Theoretical yield is a real simple formula. It's just what you actually got out of a reaction, the actual yield, divided by what you theoretically should have gotten. Percent yield. The percent yield is the actual yield divided by the theoretical yield. And then to make it a percentage, multiply by 100%. Kind of like on a test in school, the actual number of points you got is going to, in all likelihood, be lower than what you theoretically should get on all tests is 100%. So you'd get a percentage of the points right. It's kind of like that with chemistry. You actually get a yield that will never be higher than the number that you should theoretically get by stoichiometric calculations. So in this problem, my red number was an actual yield of 1 gram of aspirin. The theoretical yield that we should have gotten from the limiting reagent was 1.3 grams. And then to make it a percentage, just multiply by 100%. So in my case, I get 0.769 something, something, something. So that would be 76.9%. That's my percent yield.